In the past, we've talked about, or you guys have learned about rate of change and slope for linear functions. And for linear functions, that change is just a constant change. It's a continuous slope that's 1 over 2, 1 over 2, or 3 over 1, or 3 over 1, 3 over 1. It's the same the entire time. And it's indicated again by the slope. So even for a nonlinear function, you can find the average rate of change over any interval by finding the slope of segments that connect the points in the graph determined by the endpoints of the interval. So if you're given the interval x sub 1 comma x sub 2, two x values, the average rate of change can be found using this formula. So you evaluate the function at x sub 2 and then subtract what the function is at x sub 1. And then you take that value and divide it by whatever the x values, the difference of those two x values are. So you're essentially finding the y values and the x values just like you do for a linear function, just for certain segments. So for number 5, this one gives you a graph. So this one says, find the slope of the line segment that connects the indicated points. So from A to B, here to here, it's up 1 over 1. I'm just going to use M for slope is 1 over 1. From B to C, it's up 1 over 2. So when it gives us the graph, it's not hard. From C to D, up 1 over 4. And from D to E, up 1 over 1, 2, 3, 4, 5, 6, 7, 8. So the rate of change isn't constant, but we can find the rate of change in certain intervals or segments. Now for number 6, it says for the function f of x equals 2 to the power of x minus 2 plus 1. So it's an exponential function. It says find the average rate of change over the given intervals from negative 2 to 0, 4 to 6, and 6 to 8. What happens to the average rate of change as your x values increase? So we go from negative 2, 0, 4, 6, 8. It's increasing. And what does this mean for the graph of f of x? So the first thing we're going to do is fill out the interval and find the average rate of change for each interval. So we're going to fill out that chart first. So the first interval is negative 0. So remember, this is not an ordered pair. This is not x is negative 2, y is 0. This is negative 2 is your first x value. 0 is your second x value. So we're evaluating the function in the numerator and dividing it by just the x values in the bottom. So if we're evaluating these functions, we're going to substitute x sub 2 into our function first in for x. So we'll have 2 to the power of 0 minus 2 plus 1. That whole thing minus 2 to the power of negative 2 minus 2 plus 1. And then your denominator will just be x sub 2 minus x sub 1. So 0 minus negative 2. So I would evaluate this and I would get 1/4 plus 1 minus 1/16 plus 1 all over 2. So I would just plug that into the calculator, and instead of leaving it as a fraction, I'll just get a decimal. And it's approximately or about 0.094. You guys can leave it as a fraction, that's fine. Either way is acceptable. So then you would just do the same thing for 4 to 6. So x sub 2, and you guys can flip them too. So as long as you keep it consistent, you can do x sub 1 minus x sub 2 as long as you do it on the top and bottom. It's just like when you guys found the slope in Algebra 1 for a constant function. Just keep it consistent. But we'll keep it with the x sub 2 since that is our formula. So 2 to the power of 6 minus 2 plus 1 minus 2 to the power of 4 minus 2 plus 1 all over 6 minus 4. So that gives us 2 to the fourth power plus 1. So 16 plus 1 is 17. And then our second one is 2 squared, which is 4, plus 1 is 5. So 17 minus 5 all over 2. So 12 over 2 gives us a rate of change of 6. And then 6 to 8. So 2 to the power of 8 minus 2 plus 1 minus 2 to the power of 6 minus 2 plus 1 all over 8 minus 6. And you've noticed that the denominator is consistently 2 because that's just the interval that we're choosing here, or that it's asking us to find. So 2 to the 6th power is 64 plus 1 is 65. And then 2 to the 4th power is 16 plus 1 is 17, so minus 17 all over 2. So 65 minus 17 is 48 divided by 2 is 24. So we found the average rate of change, but up here, number 6 originally asks us, what happens to the average rate of change as x increases? So what is the rate of change doing as x increases, and what does this mean for the function? So if you notice, we do have a positive slope. So it is going up because it's all positive numbers. It's not negative values. So the average rate of change is continuously positive. And our slope starts as a very small decimal. So if you remember, a slope of 1 over 1 is not as steep as a slope of 5 over 1 because that's up 5 and right 1. So the larger the number, the steeper the slope. So if we go from 0.094 to a slope of 24 or a rate of change of 24 in one interval to the other, then that just means that our function is increasing very quickly. So it's not going to be a steady rate of change. It's going to start sort of slow and then get very steep. And that is, if you remember, what your exponential functions do normally look like, and that's the type of function that we have, so that makes sense. The last function is a log function. So again, both functions that we've done in the past, exponential and now log, we've got negative log base 2 of x. So it says find the average rate of change over the intervals 1/8 to 1/4, x is 1/4 to 1/2, and x is 1 to 2. So for this, it's going to be the same idea. You evaluate for your functions on the top, the difference, and divide it by the difference of your x values. You'll just have to remember how to evaluate for a log function. So evaluate your function for your second x. So we've got negative log base 2 of 1/4 minus negative log base 2 of 1/8 over x sub 2 minus, so 1/4 minus 1/8. So remember, log base 2 of 1/4, so to get to a fraction, this is going to be -2. So negative -2 minus log base -3. So that's just going to be 3. And 1/4 is really 2/8. So 1/4 minus 1/8, or 2/8 minus an eighth, is 1/8. So we've got -2, which is 2, minus 3 is -1, divided by 1/8. Remember, dividing by a fraction is multiplying by the reciprocal, so -8. The next interval from 1/4 to 1/2, so negative log base 2 of 1/2 minus negative log base 2 of 1/4 over 1/2 minus 1/4. So 2 to the 1/2 is -1, so -1 times -1 is just +1. Log base 2 of 1/4 is -2 times the negative is just a 2, so -2, all over 1/4, 1/2 minus 1/4. So -1 divided by 4 is -4. And your last one, negative log base 2 of 2 minus log base 2 of 1 over 2 minus 1. So 2 log base 2 of 2 is 1, so -1 minus log base 2 of 1. Anything to this power is 1 is going to be 0 over 1. So -1 minus 0 is -1 divided by 1 is -1. So we found all the rates of changes, or the average rates of change in each interval, and then it just asks again what happens to the average rate of change as x increases. So again, looking at the rate of change, so this one, every single interval has a rate of change that is negative. And this function starts with a steeper rate of change or a quicker rate of change and gradually gets shallower or less steep or less quick. And again, if it starts quickly and gradually gets slower, it'll look something like that. And that would be your start from left to right. And that is similar to what your log function looks like. And again, that would make sense.